two holes you see on the sides, those are called risers. As you may remember from my chalk talk yesterday, or pencil talk, right? So we keep our metal fluid and we pour it all at one time. And we can keep it going a little longer with the torch. As I said yesterday, the success factor now, if you look, you'll have to take a look through the walk past it, and you'll see on this side is a small riser, on this side is a larger riser, and here I'll tip it so maybe you can see it with the camera. You got it, John? Mm-hmm. Okay. So you all take a quick look. This side is a small diameter riser. Who knows what a riser is?
Where the air comes out?
That's where the air comes out. So you pour in, the air comes out. And we are still having, can you see the red? Not ready to quench yet. See the red color there? Okay, wait for black heat. And then we'll see how we come out. Alright, this is a smaller diameter riser, this is the larger diameter riser. And if I hold this up against something white, you can see it better. So you can see the longer one was more effective. So when you're doing risers, you know, bear that in mind. Now, part of the problem with the risers on this particular casting, you can see we've got a thick sprue, and then a secondary sprue because, you know, it's thin where the sprue joins it and it's thicker at the top. This is just absolutely backwards of how you should sprue something, but you can make up for it by putting a secondary sprue in there because, you know, the way the metal cools, it cools from the outside in. So if you have a bottleneck, it'll get thin, and set this down like this. And if it comes to a bottleneck and then there's another thick part on the other side of the bottleneck, it freezes up. So let's say you had a big mass here and a big mass here connected with a little thin spot. And let's say the metal came in from this side, this direction, like my wrist would be the sprue, proper sprue, and this side is going to suffer greatly. And what happens is you'll get what's called cooling porosity, and that's as the metal shrinks, it needs a reservoir of molten material to feed it. Because if it does not have that, if something starves it off, as it cools, the crystals get bigger and bigger and bigger until there are visual gaps between the interstices of the crystals. And this is what you call cooling porosity. If you look at it under a microscope, it looks kind of like frost on a window. It's a very crystalline structure. And all metals are, in fact, crystalline structures. But you don't want the crystals so far apart, you got gaps between them. Looks pretty under a microscope, but if you got that problem, you got to fix it. You got to fill it or whatever. So anyway, we can see that the gravity pour method is effective, but it is not cost effective in terms of the material required to cast it. Because we have probably about a 1.5 pennyweight casting, and we've probably got 3 times that much invested in the sprue system. Okay, so that's the gravity pour.